Now that we know how to graph exponential functions, we want to make sure we can also graph their inverse, the logarithmic function. Since they're inverses, as we talked about in class, we should see that the graph of the logarithmic function is just the reflection of the exponential function over the line y equals x. So if I look at the two different types, we could have where my base is greater than 1. If my base is greater than 1, remember that my exponential function has the point 0, 1, so my inverse, the logarithmic function, is going to have the point 1, 0. And it's going to have that asymptote. And it'll look something like this. So notice that my domain is the range of my exponential function, and my domain goes from getting super close to an x value of 0 but never touching it, all the way up to infinity. Notice my range is going all the way down to infinity and then all the way up to positive infinity. My asymptote on the exponential function was the line y equals 0, so now it's the line x equals 0, since now we have a vertical asymptote. Notice my x-intercept is now 1, 0, and I have no y-intercept since I have that vertical asymptote there. If I looked at what my graph looked like if my base was between 0 and 1, I would still have that same x-intercept. Now I'm going to look something more like this, and it's again the reflection of that exponential decay. And so again, labeling my domain, range, asymptote, so my domain, again, notice I have that vertical asymptote at x equals 0. So once again, I'm going to get really close to 0 but never touch it. But I am going to continue on to infinity using all the rest of my x values. My range, notice that I have all of my large y values as well as all of my small y values, so I'm going to go from negative infinity to infinity. Again, I have that asymptote at, so I'm going to go ahead and be a little more specific and say vertical asymptote at x equals 0, which I also could have done for the other function. An x-intercept of 1, 0, and I have no y-intercepts. Just like with exponential functions, when I graph logarithmic functions, all my translation rules are going to still be present. So if we look at graphing four separate pictures or four separate functions with logarithmics, I notice in the first one I have base 10, so I know that what my shape is going to be. I'm going to go left 3, and I'm going to go down 1. So kind of like I did with the exponential functions, I know that my intercept would normally be right here, and my asymptote would normally be right here. So I'm going to shift that left 3 and down 1. So going ahead and going left 1, 2, 3, and then also down 1. My asymptote also is going to shift left 1, 2, 3, and then going ahead and drawing it in. And I kind of missed my point there, but it should look something like that. Looking at the second one, now I see I have a negative out front, so I see I want to reflect over the x-axis. I also want to go down 2. I know that that's being subtracted on the outside because if it was on the inside of my function, I would have parentheses similar to what I have on number 1 there. So I know that my intercept is typically right here. So if I'm going to go ahead and make that go right 2, 1, 2. Oh, and I had, I'm sorry, it goes down 2, not right 2. Down 2. It should be right here. Notice that because I'm not going left or right at all, I'm not going to change my asymptote. So my asymptote is still going to be here at x equals 0. My function would normally look something like this. Because it reflects, it's going to look something like this. So when it shifts down 2, I should have a logarithmic function that looks something like that. Looking at my third one, I'm subtracting on the inside, so I'm going to go right 2, and I'm adding on the outside, so I'm going to go up 1. So normally I'd be here. If I push that right 2 and up 1, Notice that my intercept moves to here. My asymptote also moves right too. So I have an asymptote here now, and my function looks something like this. Again, keeping that general shape. So very similar to what I did with the exponential functions, where I use my shifting of my intercept and the shifting of my asymptotes, or my asymptote, to really help me determine where my function is, similar to what we looked at when we looked at that rational function. And then finally on the fourth one, I see I'm going to have a vertical stretch of 3, and I'm also now going to reflect over the y-axis, since I have the negative on the inside. So normally my intercept would be here. When it reflects over, it's going to be here instead. My asymptote doesn't change at all, so since I normally would look something like this, when it reflects over, notice it's going to look something like this. Again, my asymptote's not moving, so I do look something with that same general shape. It's really hard to show, remember, that vertical stretch like we talked about in class, so I'm just making sure to acknowledge it here. But that is about it for graphing logarithmic functions, so make sure you know your two possible shapes. And then again, being able to determine where your asymptote and your intercept move to is really going to help you with putting in that graph. Any questions you have, please bring them with you to class. You can talk about them then.